Good morning, good afternoon, good evening, AP environmental scientist. Today we are going to look at the carbon cycle, not the carbon cycle, the phosphorus cycle. We already looked at the carbon cycle, and the sulfur cycle, the saucer cycle, the sulfur cycle. Just so you know, there's a couple of things in your notes that we can just jot down that we've done. And this is the Unit 2 guided notes. There's a couple of things that we might not do. There's only one thing that you really need to not have filled out. I'm putting checks next to everything that we've done either in class or outside of class. The one thing you don't need to worry about at this point, I'm just going to put a soft X right there, is the hydro power energy focus. We did the watershed calculations, the carbon cycle. There was a video on that. We didn't necessarily get into much of this warming here, but it's been a constant subject of our dialogue. The positive feedbacks, I'm going to put a soft X through that, the implications of the warming. We're doing this today in class, at least depending on when you're watching this video. But that is something that is going to be done in class. And all the way down to that. That was covered in a video. And now we're at the phosphorus cycle. So the phosphorus cycle, basically, you have the vast majority of the phosphorus on Earth is stored in a rock. And this is phosphorus ore, which, just to step back here, phosphorus, why is it important? Well, phosphorus is important because it's key components, much like nitrogen we talked about last time, of nucleic acids in human beings. It's a key part of nutrients for plants because they have nucleic acids, RNA, DNA, proteins. And the most of the phosphorus, the most common form of phosphorus, is a phosphorus compound called phosphate, which phosphate is PO4 3 minus. And so if you were mining this rock, you would then have to put it through a chemical extraction process to actually get the phosphate out. So let's talk about the sulfur cycle a little bit down here. Let's just draw this out and then summarize how it's different than other cycles. And so just kind of the natural way that phosphorus moves. So most of phosphorus in rocks. So here's just, I'll put phosphate rocks. And I know there's some things that are a little bit difficult to see on your screen. And the wind and the rain will erode and transport phosphorus down to bodies of water. So here's just phosphorus being eroded and transported. And then it will go into bodies of water where living things will pass it along in their food chains. I'm just going to put food chains here, right? Plants will pass it to animals. Animals will die and decompose and pass it back to plants as it gets into the soil. And then over time, phosphorus will actually turn into sediment, right? Sedimentation. And that's just when it turns in, settles at the bottom. And then eventually over large geologic time, that can actually go back up into a mountain. This whole thing, tectonic plates will sometimes uplift the ocean bed. And next thing you know, you have phosphorus at the top of the mountain again. Other kind of natural ways, you'll see uptake from the soil into trees. You'll see it passed again along the food chain from animals to trees to animals back to the soil. That would be decomposition if an animal is giving sulfur back to the soil. We're not going to worry about this arrow right here. And then save these two on the left-hand side here because humans do interrupt the phosphorus cycle. The big way that we interrupt the phosphorus cycle is through mining. We mine sulfur. And we mine those for industrial uses. It's in a lot of chemical products. But what are the main the two main things that we use phosphorus for are fertilizers And this can cause some major issues, as we'll explore next class. And then the second thing is for detergents, right? If you took a shower today or yesterday, then chances are you used a phosphorus-based detergent. So these detergents can often run off, or these fertilizers can run off. And so I'm going to put runoff here and runoff here. And that phosphorus runoff can cause excess nutrients in these bodies of water, which that then has a cascade of effects, which is important for us to discuss, but not for this video. So what's the unique thing, and probably the number one AP question about the phosphorus cycle? What do you notice? I guess human impacts. We mine phosphorus for detergents, fertilizers. That's the main human impact. So what's different? What's unique? What's one of the big take-home messages? That's right. Did you see? It has no atmospheric component. It's the only cycle without an atmospheric component that we're going to cover in this class. It has another way of saying that it has only terrestrial components. So terrestrial, I've mentioned it a few times now. That means land, right? Land components. Land and water components. But a better way to just say that is no atmospheric components, only terrestrial. I should say terrestrial and marine / aquatic components. Marine usually refers to salt bodies of water. Terrestrial refers to land. Aquatic generally refers to freshwater, but it can also refer to marine as well. There's some overlap in terms of those terms. We covered the nitrogen cycle, and then we summarized the nitrogen cycle in class. And these are all things we're going to do in class when we build your eco bottles. So we talk about what could happen in your eco bottles. And then, so I'm going to go ahead and skip to objective 9, and that is all about this rock. And I went yesterday just to take a whiff of this rock, and here I am.
You know what I love about the sulfur cycle? You can always smell it. Here we have a nice pool of dead, decaying organisms, stagnant water, hydrogen sulfide being emitted. It's the sulfur cycle right up our nostrils. Sometimes you'll smell that at the beach too, where all the wave action actually liberates a lot of the hydrogen sulfide and promotes some of that action too. I'm gonna go now before my kids jump into this sulfur pool. Maisie, Arlo, Augie, you wanna say hi for the camera? What are you doing? Maisie, what are you doing? Arlo, what are you doing?
And I'm about to fall into a river with bird poop.
Don't do it!
I'm about to pick up a bird bone in the water.
Don't do it!
Thank you for putting up with my family. Sulfur. Hold on, the lights just turned off on me. That's what happens sometimes early in the morning here in room 2. The sulfur cycle. Sulfur definitely does have an atmospheric component. In the atmosphere, you'll often see sulfur as SO2. The smelly rotten egg smell is H2S, so that's sulfur dioxide. And that is hydrogen sulfide. We'll talk about how those get down to the ground. Down here on the ground, most of the sulfur is in rocks. You'll see lots of sulfur in rocks in the form of phosphate or in even pure elemental sulfur form. And ways that this can come up to the surface. Well, there's a couple of different ways, but some of the major things to know, just to break it down to the essential things that you need to know, is sulfur is released from the Earth's crust one of the major ways, and you can smell this if you go to a volcano, one of the major ways is through volcanoes. That releases SO2 and H2S. And then the major human disruption to the sulfur cycle is when we burn coal. Coal, one of the reasons it's considered the dirtiest of the fossil fuels is because it releases lots of sulfur dioxide. And the important thing to know at this component in this course is that sulfur dioxide can combine with water, and suddenly you have something called H2SO4, which H2SO4 is sulfuric acid. That is sulfuric acid. And sulfuric acid is the main component of, it's the most common component, I'll say, of acid rain. So then that sulfur can come back down in the form of acid rain down to the land, and that can cause bodies of water to have lower pH, right, in bodies of water. And sometimes that acid rain can also dissolve metals in the soil, which those metals can then be carried to bodies of water. So acid rain has a lot of detrimental environmental impacts. Again, we'll talk about it later during air pollution, but just for now, know that it can lower the pH of bodies of water. It is not responsible for ocean acidification. The ocean is too big to be acidified by the amount of acid rain that we're talking about, but lakes, rivers, streams can lower the pH. And then, like I said, it can also release metals in the soil, which if you're releasing metals in the soil, something like mercury, that can be very detrimental to an ecosystem, because suddenly this mercury that was stored in the soil, which mercury is a powerful neurotoxin, has now been released because it was dissolved by acid rain into a body of water. That's it on the sulfur and the phosphorus cycles. Thank you all for hanging out today, and I will see you soon.